For this speaker build, I will be using the Creality Falcon 2 laser engraver. This desktop diode laser engraving machine has a power of 22 watts and can cut 20mm thick wood as I've tested in my previous video. The standard honeycomb bed that the laser comes with is rather small, so I'll replace it with this large honeycomb bed from Creality that will allow me to use the full working area of 400 by 415mm. The platform is made from galvanized iron frame with aluminum edges and rubber corners for protection. This sheet of aluminum is placed below to avoid damage to the workbench. This much larger honeycomb bed will now allow me to use the full potential of the laser engraver size and will reduce the waste because I'll be able to use larger pieces of wood or other material for engraving and cutting. With a power supply and USB cable connected, I can turn on the machine, but before I do any cutting, I will cover the laser with this foldable enclosure to easily extract any fumes and add a layer of safety from the laser beam. I reconnect the power supply and USB cables, the air assist hose and the fume extraction hose to my slightly modified exhaust port. For this speaker build, I'll be using 4mm plywood, so before cutting out the parts, I will cut a test grid on this piece of plywood so I can determine the optimal speed and power settings for clean cuts. The laser module height is adjusted manually by placing the included guide between the laser module and the workpiece. Once the focus is set, I frame the laser to check if the cuts won't be out of bounds of the material. The air assist does a really good job of leaving a clean surface with very minimal burning marks around the cuts. The test grid clearly shows what settings to use for cleanest cuts for this material, so now we can move on to making the speaker. I designed the speaker enclosure that will be glued from 21 layers of plywood and will have 10mm thick walls. It will fit a full range driver, a tweeter, a passive radiator, an amplifier, crossover components, and even a battery to make it portable. With a large honeycomb bed, I will use 40 by 40 cm plywood pieces to cut out the parts. After focusing the laser module and checking the outline of the cut, I turn on the exhaust fan and let the laser cut out the frame pieces. With the right settings, the parts are cut out with very minimal burning on the edges. After about an hour of cutting in total, the enclosure parts are cut out smoothly and the laser had no issues cutting out even these small holes for the screws. The whole speaker has to be glued layer by layer, so I use a paint roller and apply an even coat of PVA D3 wood glue on both surfaces, starting from the front of the speaker. I carefully align the layers, cover them with the film and use my heavy subwoofer as a weight to press down on the pieces while the glue dries. And just like that, I go by gluing 2 layers at a time so each layer has enough time to dry and stay flat. While gluing the layers in 2 takes more time than gluing each layer on top of another, this will help to avoid any shifted layers in the enclosure and will keep it straight and accurate. Now that the pairs of layers are dry and flat, I will continue gluing them one on another, making sure they are well aligned before leaving them to dry. Wiping off any excess glue with a damp rag will make it easier to sand the edges later. And now that the layers are glued in groups of 4, I can apply the last layers of glue and leave the enclosure to dry completely. Because the plywood that I used wasn't the best grade, there were a few small holes that needed to be filled. For that, I'm using 2-component epoxy with some sawdust mixed in. When the epoxy is fully cured, I spend a few hours sanding down the enclosure to reveal the smooth plywood layers. For the finish, I'm using water-based semi-gloss lacquer that I apply with a soft brush. Once the first layer is dry, it leaves a rough finish, so I lightly sand the surface and apply the second coat on the enclosure and the back panel. While the speaker enclosure is drying, I will make the carrying handle. I have this strip of soft faux leather that will be perfect for a handle, so I measure the length and place it on the laser bed for cutting. After a few minutes, I have a precisely cut end of the handle that I will repeat on the other side. I really liked how the embossed logo turned out on my previous speaker build, so I'm cutting a template with my logo on a piece of plywood. I am gluing the pieces together to make the embossing tool and using the stencil to glue each letter on top. Using a few clamps, I press down on the handle and leave it like that for a few hours. After removing the clamps, the logo becomes visible on the handle. I will cover the laser cut edges of the handle with a bit of silicone. Now I'll run an engraving test pattern on a scrap piece of plywood to get the color and depth that I like for the engraving on the speaker enclosure. Because the laser is too low to fit the speaker enclosure, I will use these machined riser extensions from Creality to make the engraver taller. Here I am marking the charging port location on the side of the speaker. I can now focus the laser on the enclosure and carefully adjust the position of the laser beam. After a few passes, the charging port is cut out cleanly through the 10mm thick frame. But I could have made a second pass on the letters because not all were completely engraved, most likely due to the glossy finish of the surface. I am now setting the laser to cut out the holes for the carrying handle. Once again, the laser had no issues cutting cleanly through the frame. All that's left is to cut and engrave a hole for the amplifier. Here I am placing a box of screws inside the enclosure just to weigh it down so it does not move while cutting. After aligning the enclosure to the laser frame and adjusting the focus of the laser module, I set the laser to engrave and cut the hole. And finally, as a small detail, I will engrave my logo on the front of the speaker. With my logo finally engraved on the front, the speaker enclosure is finished and we can move on to the build. Thanks to Creality for providing the Falcon 2 and making this project possible. Now let's take a look at the speaker components that were provided by Sound Imports. These include the crossover components, a tweeter, a 3.5-inch driver, and a passive radiator. Because this is a mono speaker, it will use a single full-range driver paired with a tweeter and a passive radiator in the back for deeper bass. The Dayton Audio ND91 is an amazing driver for compact speakers with phenomenal low-range performance and power capability considering its small size. The Dayton Audio ND16 FA tweeter should give the speaker some sparkle without overpowering the overall sound. The crossover consists of 2 coils, 2 capacitors, and 3 resistors. Thanks to Sound Imports for providing these components, and now let's take a look at what other parts will be needed. For the amplifier, I will be using this mono-channel Class D unit with Bluetooth that should be capable of delivering 30 watts of power. To make the speaker portable, I will use 4 lithium-ion cells together with a BMS board for battery protection. The batteries will be charged by USB-C through a charging board. I start by arranging the battery cells in the holder, and I'll use my spot welder to make the connections between the cells. This is my secure spot welder that has been producing great results for many of my battery builds. To power it, I'm using 2 LiPo batteries connected in parallel. I adjust the welding poles and place a strip of nickel across 2 battery cells. Just 2 welds on each cell is enough to make a very strong connection. Now I flip over the assembly and weld the following cells. I also weld a thin tab on the negative and positive ends for soldering wires later. With a piece of insulating paper placed on top, I am now attaching the BMS board using a few strips of double-sided tape. I can now solder the wires to the board. While it may seem complicated building your own lithium-ion batteries, it is actually quite simple and straightforward, but to do it safely, you must use good quality cells, a spot welder, and a BMS board for monitoring the voltages. After soldering the BMS board, I check the voltage on the output to make sure it's connected properly. I'm using a JST connector for the output cables. The battery ends are protected with insulating paper, and the battery pack is covered with heat shrink film to finish it off. Before mounting the speaker driver, I place the gasket and then use these M4 screws with a small spacer I cut out of plywood on the laser. I'm using strong construction adhesive to glue the battery in place. The glue is flexible once cured, so it will absorb any vibrations. I am now gluing the tweeter in place with a few drops of CA glue at first. The USB-C charging port is installed, following with a bit of sealant to make sure the enclosure doesn't leak air. The power cables can now be soldered to the charging board. While the glue is drying, I will assemble the crossover. There isn't much space inside the speaker, so this configuration of the crossover components worked best to fit it inside. Before gluing in the crossover, I'm screwing in these pins for attaching the handle. I can now solder the wires from the crossover to the woofer and tweeter. Since I won't be using the aux port, I will trim it down so the amplifier can sit flush. After connecting the amplifier to the crossover, I apply a bit of sealant around the potentiometer and install the amplifier, securing it with a washer and a nut. With the amplifier knob in place, I connect the amplifier to the battery and hot glue any loose cables to prevent rattling. This adhesive foam gasket tape will keep the enclosure airtight. The back panel can now be installed. The passive radiator has a gasket pre-installed, so I place it on the back panel and screw it down. I now attach a set of silicone rubber feet on the bottom. And with the handle installed, the speaker build is complete. The speaker can now be charged through the USB port. I think the speaker turned out quite well. It has some pleasant weight to it, making it feel high quality, and the surface of the plywood is very smooth to the touch with a polished semi-gloss finish. The speaker is turned on by pressing the volume knob, and it can even connect to an app to adjust and change a few basic settings, like renaming the Bluetooth device. The amplifier itself is surprisingly powerful for its size. It is able to fill a large room with clear bass and quite well-defined mid and high frequencies. The speaker actually has difficulty staying in place at a volume of over 90% because of the moving mass of the speaker and passive radiator. For comparison, I'm using the Marshall Stockwell 2 and will leave you with a few audio samples of both speakers playing at around 80% volume. If you'd like to build a speaker like this yourself, feel free to check the description for build plans. If you like this project, I hope you will consider subscribing to my channel, so thanks for watching and I'll see you on the next project.